Hi, in today's video, we will discuss the transformation of trigonometric graphs. So let's get started without wasting much time. Before we discuss the transformation of trigonometric graphs, there are a couple of terms that you should know, and they are the amplitude, the frequency, period, phase shift, and vertical shift. Let's understand them one by one. To explain the transformation of trigonometric graphs, I'll be using sin x as the original function. Based on that, we will discuss all type of transformations. So here on screen, you see the graph of f of x equals sin x, and we want to graph g of x, which is equal to a times f of k times x minus b, where a is called the amplitude, k is known as the frequency, and b gives you the horizontal phase shift. And we can include plus c, which will give you vertical shift. And obviously, we'll talk about the period as well. First, let's talk about the amplitude, how it affects the graph of y equals sin x. Here, I have set amplitude as 1, but if we change this amplitude to 1.6, 1.7, 1.8, 2, what do we observe here? If we compare it with the original sin x function, you see that the height of this graph has increased. It is more taller than before. Now, what happens if we decrease the value of a? The height of the graph decreases. So that's the role of amplitude. Now let's talk about frequency and how it affects the graph. Here, for f of x equals sin x, k is equal to 1, means the frequency is 1. That means in an interval of 0 to 2 pi, there is only one cycle which is completed. But if we change this value of k to 2, now you see that one cycle is completed in 0 to pi. So in an interval of 0 to 2 pi, you will have 2 cycles completed. And if we continue this, you'll see the new graph or graph of sine 2x. And if you compare it with the graph of sine x, from the graph, it is clearly visible that the graph of sine 2x has 2 peaks in the period of 0 to 2 pi. However, the graph of sine x has only 1 peak. That means the graph of sine 2x is more faster than the graph of sine x, or we can call the frequency is greater than the frequency of sine x graph. Here, we can make one important conclusion that period of any trigo function is 2 pi divided by modulus the value of k. So for example, in this case, for sine x function, the value of k is 1. So you have the period as 2 pi divided by 1 or 2 pi. But for sine 2x function, the period is 2 pi divided by 2 or pi. And that is why one cycle is completed in pi radian. Now let's talk about the phase shift or the horizontal shift. For horizontal phase shift, if we change the value of b, and now on screen you have the graph of sine x minus 0.72. And if you compare it with the graph of sine x, it is shifted by 0.72 towards the right side. And if we change this value to a negative value, we will see that the graph will shift towards left. Do you know the reason why? Yes, you're right. Because when you set the value x plus 1.28 equals 0, it will give you the value of x as negative 1.28. And negative 1.28 is towards the left of origin. Whenever we're trying to draw f of x plus a, then the graph shifts towards left by a units. And whenever you're trying to draw f of x minus a, the graph shifts towards the right side by a units. Now, moving on to the vertical shift. If we draw the graph of sine x plus 1, we observe that the graph is shifted 1 unit upwards. And if we draw the graph of sine x minus 1, the graph is shifted 1 unit downwards. Now let's look at some examples combining everything that we have learned so far. So let's start by changing the amplitude first. If we change the amplitude to 2, the height of the graph will increase from 1 to 2 on both sides. So it will be 2 units upwards, 2 units downwards. And now let's change the frequency from 1 to 2. And you see that now in the interval 0 to 2 pi, you see 2 cycles instead of 1 cycle. And let's try the phase shift. So if we increase the value of b from 0 to 1.57, the graph is shifted 1.57 units to the right. So in this video, we discussed how the amplitude, phase shift, frequency, and vertical shift affect the graph of any trigonometric function. In the next video, we will talk about the trigonometric ratios for any angle. So this is it for today's video, and I'll see you in the next one.